Hi, everybody. Welcome to Customizing Anything, Embracing Mutable. My name is Dustin DeVoe. I'm a technical animator on the Tech DevRel team at Epic. And today, I want to go over a plugin that's been in Unreal for a little while, but it just went into beta called Mutable. And we're going to go over what it is, some use cases for it, as well as I'm going to do a hands-on demo showing you guys how to use it. In Unreal Fest Orlando, Gerard Martin, who's a part of the Mutable team, did a presentation about Mutable as well. And much to my chagrin, there was quite a bit of overlap. So his presentation goes over kind of some deep dives of how the system works. I'm going to show you guys how to use it and get started, because a lot of times new studios and up-and-coming smaller indie studios want to use something like this, but it's a little daunting to get into. So what is Mutable? At the end of the day, Mutable, simply put, is a tool for customizing and merging meshes. So this comes with some caveats associated with it that I'll show today, but it has a big feature-rich tool set to do this, to make efficient, optimized meshes for your game for a bunch of different cases. It has a couple strengths. The first one is that it's got async runtime and baking features to generate these meshes. You can use it at runtime and load these things into memory and use them in your gameplay. Or if you want, and you can't afford that, you can still have your customization options. Take all these meshes that you want to combine, put them into a customizable object, and bake them out to create a whole suite of characters for crowds or NPCs or things like that. The other thing that it does is that you can edit and modify your meshes and your textures. And I'll show that in the demo today. And it's got support for expanding content. If you're working on a live service game and you need to add content over time, you can still add more to the system and still create those efficient meshes for later on in the game's life cycle. So what would you use this for? The first thing that comes to mind is character customization. So oftentimes when we're building a character customizer, you think about it in parts and slots, and you can combine those together to reduce the overall component count for your characters. On top of that, you can take objects that have a similar root skeleton and combine those together. The example that I often use is you have a character and you want to add a backpack to them. You can do that as long as the root chain in that skeleton is tied together. And I'll show that later too. And you can apply mesh edits like morph targets, mesh removal and adjustment, as well as handling overlapping meshes. So you can see here in this image, we've got a t-shirt, and I want to tuck the arm into that t-shirt. You can modify the mesh at that tuck point on a per object basis. The other thing that you can do is you can do texture and material customization, applying player-chosen textures and material edits, as well as generate atlas textures that are efficient for the runtime. And you can do texture projection. Think like decals. I have a jacket and I want to put some patches on it, or I want to do tattoos. And you can position that as a player, or you can position it ahead of time in your customizable object graph. The other area that you can use this is in modular attachments and systems for things like weapons that are more static, but you still want to combine parts together to create guns that have scopes and things like that. Just think of them like characters, and all the other systems apply. And then lastly is vehicles is another use case too. So similarly, you can attach things to chassis, combine those all together, output a skeletal mesh to use in something like KS Vehicle, for example, that can drive those skeletal meshes. Okay, so I'm going to get started with a demo, and we're going to start creating our first customizable objects. And this is going to start at the basics so that everybody can kind of follow along and take this moving forward into their studios and start trying it out. Okay. So I've loaded up the Mutable sample, and we're going to use this as the basis of our content to start building things out. We offered the Mutable sample with Unreal 5.5 when Mutable went to beta, and it shows how you can use Mutable. But if you were to open it up, it can be kind of daunting. So let's start by creating our first character. So assuming that you have the mutable sample loaded and the plugin loaded, you're going to right-click, you're going to go over to Mutable, and you're going to create your first customizable object. We're going to call this CO Simple Cyborg with a capital Y because keyboards. Okay, so you'll notice that this graph is empty. It's a typical blueprint graph. It has nodes that are associated with it for how you would set up your character. And there's other stuff like your details panel. But over here in the preview instance, you're going to be able to see not only what your preview asset looks like, but what content it's generating on the fly. So you can see the output of all your combinations as you're going. So I'm going to name this object. I'm going to switch back. There we go. I'm going to name this object simple. I'll name it body, for example. And the first thing that we're going to do is we're going to bring in meshes for us to work on. So if I bring in the body, bring in a skeletal mesh, you'll notice it brings in all of the information that's associated with that mesh. So we don't have to work on all of these. We have access to every LOD and section that's associated with that skeletal mesh, so we can work on each individual part and do customizations per LOD if we want. Today, we're not going to do that. We'll just work on LOD 0. But you'll also notice that I get access to the morph targets, so I can apply and use those morph targets to generate new mesh data, as well as information about textures and materials for each section as well. And there's a lot here to work with, but if I hide all this, I'm going to just expose the meshes for LOD 0 for the eyes, the head, and the body. And we want to make sure that we have eyes because creating a head without eyes is always kind of creepy. So I'm going to first extract the section information from the head. So this is where we start to define what objects and sub-objects we're going to be working with. And so when I select this mesh section, this represents the slot and the material associated with that sub-mesh of the skeletal mesh that we've pulled in. And this is where we can start to modify and adjust UVs, as well as pass through different texture information. And I'll show all that. Then from there, we're going to add a pin called a mesh component. We're going to call it body. And this node here represents the skeletal mesh component that we're going to apply into our blueprint, just like you would if you were to drag a skeletal mesh into that blueprint. So I'm going to plug this in. And if I compile this, it's going to error, which I did this on purpose because ultimately, we need to apply a reference skeleton, which is attached to this mesh component. The skeleton inside of Unreal for all skeletal meshes is the basis and the foundation of how we're going to play animation and stuff. So that needs to be predefined. So I'm going to compile this. And awesome, I have a head. Great. But now, what if I want to add these parts together? So mesh section again. Apply this here, mesh section. Oops, apply this here. Now, today, this is something that you have to do. It's not as quick and easy. We want to do a user experience pass. The plugin is in beta after all, and we want to make this part faster, better, stronger. So I've gotten our eyeballs, our head, and our body, and if I compile this, awesome, I have a combined mesh, and if we look at our generated instances, I'm outputting a skeletal mesh, and I've already reduced the mesh materials and sections for this body by combining the eyes. Great, I completed the same thing that I kind of imported at this point, and that's not very fun. So let's start layering on clothing on top of this. So I'm going to go to here, I'm going to grab some pants, and I'm going to grab a t-shirt, not the whole folder. There we are. Okay. So now that I have these skeletal mesh objects, I'm just going to work on LOD 0 of this. And I want to add these to this particular mesh component. And I have these other skeletal meshes. But if I were to create another mesh component here, it would double up the amount of components that I'm outputting. So I'm going to grab the mesh section and grab the mesh section here. And the next one I'm going to use is add to mesh component. And we want to name this node the same node as the mesh component that we're applying this to. So I plug these in, and I output this component. And now I've created a character that has pants and a shirt. It's one mesh, and it has these sub-meshes here with their mesh sections. Still more optimized than having them all together, but now I can have one skeletal mesh component inside of my actor that references this mesh, and not 3 different separate meshes that I have to drive and consider what's going to happen with the animation. But we've run into our first problem. The first problem here is like, oh no, I've got skin poking through. And we've actually hit the point in which Mutable starts to do something that's really, really powerful. So the first one that we're going to do is remove mesh, and I'm going to choose remove mesh blocks. And this gray node is called a modifier. And you notice here that this graph is empty. So I'm going to connect this up. And the first thing I need to do is I need to associate this mesh block removal with what mesh am I removing. So Mutable does this via tags. So I'm going to go up to the body mesh section here. I'm going to add it called body. And then I'm going to go down to the remove mesh blocks, and I'm going to search for body. And as soon as I do that, I now have access to the UVs of this mesh, and I can do stuff with it. So this particular node and modifier, what it does is if I add a block here, it will, anything that's within this blue block will be removed when I compile this. But this isn't very granular. It's a 4x4 grid. For efficiency, there's a power of 2 kind of setup for the grid size. We're going to set this to 32 each. And then what I can do is I can grab and move this section to cover that. I'll add another one here so I can cover the kind of the front chest bit. And now, if I were to compile this, I've automatically removed that chest mesh data. And what this does is it's not doing anything with a material or anything like that. It's literally removing the polygons from underneath the mesh. So you can see the arm kind of goes there, and the legs are still there, for example, but the chest is missing. So that's one way of removing the mesh. Another way that's probably a little bit more efficient is called a clip mesh. So clip mesh with mesh, and I can plug this modifier in, and I can associate that with the body section. And then what I can do is I can pull in any sort of mesh into this, and I've got one here called like weapon clipping for now. If I pull this in and I plug it into our graph here, I get a representation of that block that I can now position. And anywhere that I place that block, it's going to hide that section of the mesh. So I'll show you really quickly what that looks like. Because I'm modifying the body, I'm just going to cover up the arm here. And I compile this. I've now just erased the arms where that mesh is. So I'm going to do this with the pants here. Now this isn't the best block, and you can actually, again, you can use whatever mesh that you want, but because I'm using the sample, I'm just using what I got. And I'm going to resize this. I can do this with multiple meshes as well, so I can add multiple modifiers. There's no cost to having those multiple modifiers outside of compilation time, but in the end, it's very minimal, not too much to worry about. And it's looking pretty good right here. So if I hit compile, I now have a pretty efficient combined mesh that removes all of that under mesh. And if I double click the output, this is completely in memory. And it's all skinned, ready to go. If I go to the spine here and I rotate it, all of the skinning information comes across, and I can use this in runtime. So that's cool. We've handled some of the mesh generation needs for having efficient meshes, but this isn't really a customization object. So let's get started in our first customization. I'm going to grab from the content drawer. I'm going to go to the character. I'm going to grab a tank top here, get another shirt in this. And I'm going to kind of move this stuff out of the way. Work on LOD 0 for now. We're going to get the mesh section. This is a very common action. And now we can add our first parameter that we can start to drive our instance. So if I type switch, this switch node, and there's a bunch of different types. There's a color switch, component switch, float, mesh section. These are all abilities to be able to drive via just an enum, a switch that you can push different data through the graph. So I'm going to do mesh section switch. And I'm going to pull a pin off of the switch parameter. I'm going to create an enum pin. I'm going to call this shirts. And then I'm going to add in our shirts. So t-shirt and our tank top is what it's called. OK, so once I add in those new parameters, I can hook up our mesh sections. So if I do this, can put our t-shirt into 0 and our tank top into 1, and then I can plug this into our add and compile. And now I should have access to a variable on my instance. And if I open this up, I can swap these. And now I have my first customization where I can swap meshes depending on which subsection. And you'll notice right away that I've kind of have my clipping mesh here that I hid is a part of this. So you can have giant graphs where I can now take this enum here and start to plug it in and say like, okay, well, I want to use this modifier if this state is active and everything like that. We can start to grow our graph, but that kind of gets unwieldy. So ultimately, with the tank top, I want to run some logic, but on the t-shirt, I want to run different logic. So to do that, we're going to go up here and we're going to introduce a new concept called child object or object groups. And I'm going to name this object group shirts. And this node right here becomes an entry point into the graph where I can now hook other customizable objects and pump it through this section of the graph. So now that I've named it shirts, up in the top, there's a group info type in the properties. And there's a couple things in here. There's toggle, all options, at least one option, or one or none option. So I'm going to choose one or none for now, with the default being none. And what I can do is, if I compile this, really nothing's going to happen. There's no child objects for it to understand. So I'm going to go to the content drawer, and I'm going to make a new customizable object. I'm going to call this CO t-shirt, and I'm going to open this up, and I'm going to name this t-shirt, just like we did with our enum here. And I'm going to go back to my simple cyborg, and I'm going to grab the t-shirt data. I'm going to cut that out. I'm going to paste it in here, make my life a little easier. And I'm going to add our mesh component, add to mesh component node, name it body, and then plug that in. But what's going to happen, as soon as I compile this, I'm going to get an error. CO t-shirt finished compiling with 0 warnings and 1 error. And the reason that is because the add to mesh component node doesn't know which skeletal mesh component it needs to add to, because there's no relationship to that other graph. And there is no mesh component inside of this graph to add anything to. So the way that we hook graphs together now is actually from the child to the parent. So if I select this base object, and I go to this attach to external objects section, and I choose our CO simple cyborg, and then I can decide which object group I'm going to pump this data through. So if I hit this and I compile, it compiles now. I'm going to save it. go back to our cyborg, compile it, and I'm just going to unhook this here. And now you can see here there is a parameter for shirts that has none or t-shirt. And now that I've done that, I can go grab my remove mesh blocks and bring that in to here, plug that in. And then I can go back. I'm going to disconnect this other clip mesh. I'm going to compile. And you'll see now that the logic that's associated with mesh hiding comes with the t-shirt. So if you can imagine this setup for a game that is growing over time, I can download just that sub-customizable object. It goes in linked to the parent graph via that child-to-parent relationship, and now I have a way to do expandable content in my game. On top of that, all of the logic is encapsulated inside of that function. Cool. So we've created a character. It's got some customization. I'm not going to add the t-shirt setup, or not the t-shirt, the tank top setup. I think you guys get the idea. But how can I use this now? In what ways can I use this in both a baked or runtime setting? So the way that this works is I'm going to go to the content browser, and I'm going to right-click on my simple cyborg CO, and I'm going to go to create new instance. So this creates a customizable object instance. It has a very similar feeling and vibe to the main customizable object UI. And I have my parameters here. So I have a character that can wear a t-shirt and not wear a t-shirt. And I can save this. But I minimized my screen because that was a mistake. But now I can create a blueprint actor. We'll call it new blueprint because typing things can be slow. I'm going to add a skeletal mesh here. And then I'm going to add, as a child to that skeletal mesh, a customizable skeletal component. And this is the component where we can add our simple cyborg instance to it. And we're going to specify, OK, on this component, we're going to generate some data, and which of the components that I generate do I want to pump into the skeletal mesh component? So I'm going to choose body, because if you remember, in simple cyborg, the mesh component name that we have is body. And already you can see that I've created a character in here, and if I change this option to swap out parts, he now has that part. And if I go back here and change this, I have the shirtless version of that character. And on top of that, I did the thing again, but that's OK. If I were to drag this in here, I can just place the customizable object as an actor in my scene automatically. So another thing that you can imagine is if you have some environment pieces that are made with skeletal meshes, you can actually create customizable versions of those things and then plop them into your scene as well. And this is all runtime. It's not baked. If you want to bake something, I'm going to delete this. What you can do is there's a button here called Bake Instance, and you can click it, choose a folder. I'm going to make a new one. Output. And I'm going to export all used resources and generate constant material instances. Hit OK. It's going to output all of this data, and it's going to ask me to save it. But now what I've done is in my output folder, I have that version of that character. So this is how you can make a lot of NPCs that you can store on disk and not at runtime with those customizations, and then use them in your game, all through having a modular system to generate those assets. OK, so the other cool thing, if you are an animator in the engine and you want to be able to animate in context of your customizable character, you can do that as well. So I'm going to create a level sequence. And I'm going to open it up. And I'm going to go to my content drawer and add my actor from the content browser. So I've got my customizable character here with my customization. And I can add a control rig, maybe. Yep, body. I've added a control rig. And now that I have that particular instance, you can create your like animation team customizable instance. And I can go in here to my content browser, go to my customizable instance, we'll take off this t-shirt, and now all of a sudden I can animate in context with my whole entire customization system, right? And if I've worked on a game in the past where my main character had these mascot helmets that it would wear, and I had to animate cinematics with that, and trying to like place the camera correctly so it wasn't intersecting with the mascot helmet, but then I needed to also do facial animation in context was like really tough. Now you can do that with this customizable instance using all the exact same parameters and setup that you're going to use in your runtime in your game anyway. So it's really cool. Okay, so that's a basis of how we can kind of set up our a simple character customization system, but we may want to start to look at some other tools to create optimized textures and our weapons. And there's another way that we can define which assets get set into a graph. So the first thing that we'll do in our weapon example is I can create a table node, and we'll call this body. And in this table node, we've already kind of created a data table that has some information. And if we look inside of it, it has it's built off of a struct that contains a skeletal mesh and what textures associated with that skeletal mesh that are specific to use when I'm using that particular body setup. And these are pretty easy. If we look at the struct, it's just a series of like the soft object references to those types. And then we build our table, and we've got some previews in here. So if we go to our example, I'm just going to work on LOD 0 again. And we do our mesh section. Component, call this 0. And we'll plug that in. And I don't want to make the same mistake, so I'm going to do weapon, skeletal weapon reference, and I compile. And I still get an error because I need a material with that as well. So when you're hooking up a data table in a mesh section, you need to make sure that you have a material that things are going to be passed through. And if you don't share your materials, you can get into some troubles. But now that I've done this, I now have a property that's set up with our different material types, or our different body types here. And you can notice that some of them are kind of looking a little weird in certain cases, and I'll show how to fix that in just a second. So this is another way that you can define, okay, well, I have a series of assets that I want to have go through this pipe, and we want to do the same operation on all of these assets. It's not like one skeletal mesh has a whole series of operations. In general, on like a weapon example, we're going to do the same thing every time. But now I want to build a more efficient texture and mesh with this as well. So I'm going to go grab our barrel here. I'm going to paste it in. And the next thing I'm going to do is I'm going to do extend mesh section. This is a new modifier node. And I'm going to plug it in. And I'm going to associate it with our section. So I'm going to call this one body as well. And then here I'm going to grab the body. And the reference material is going to be the same material because all of these objects use the same master material. And now you've noticed that I have the the texture maps that I want to pass through to this system. And the reason why it's specifically asking for a texture map is because what it wants to do is it wants to take in the textures, combine the UVs, and then combine those textures. So I'm going to expand this a little bit bigger so we can kind of see what's happening here. So I've got a body and I've got a barrel, but the textures are all kind of messed up. And if I look at the, where's the UVs? Oh, right here. If I look at the UVs, on the left-hand side, I have the body UVs and then the barrel UVs, and they're combined now into one texture. If I disconnect this and I compile, you can see there's the original UVs. But my texture's still messed up, and that's odd. And the reason that is, and this is a quirk about Mutable, but it's important for the optimization aspect of Mutable, is that I need to define that the textures are going to be modified by Mutable itself. So the default texture parameter mode is going to be set to Mutable. And if I compile that, now, if I hide my UVs, my meshes look wrong. So I'm just going to expose these textures here as well. And on my mesh section, I'm going to expose those textures too. So it knows what textures it needs from the body mesh as well. I'm going to plug those in and compile. It's green. It's fine. It's a good demo for that particular reason. But the idea being is now I've got my generated out resources here as being the combined textures with those new UVs set up here, like this. So that's how we can atlas textures together and set up our assets to be not only efficient in their mesh and memory consumption on that side, but also in our texture and material consumption for our textures. The downside and the trade-off for the runtime is that, yeah, I'm combining textures. I need to load the originals, but I throw those away after the customization happens, and I'm being efficient with my texture usage at that point. All right, so I've shown some basics on how to combine our meshes and our textures with one minor mistake here. But there's a caveat to setting up our skeletons that I want to show. So I'm going to go to my vehicle example here. It's going to compile. And you'll see that I've pulled in some Fortnite vehicles to use. I just want to highlight this is not the way that we build vehicles in Fortnite. I just grabbed some assets to kind of show this. But if we look at our content for this, if I go to our bodies, I've got Octane, which has one structure here. It looks like this. But I also have Endo here, which has a different structure. So if I look between those, the bones are in very different positions. And this is one of the things that you need to care about when handling mutable characters and whatnot. And what I want to show you is how to fix this particular issue so that we can combine these things. So I'm going to shut these down. And inside of this instance, I've already set up our body, some wheels, and a spoiler here. And if I go into our instance parameters and I change this to, need to add in the endo setup. So I'm going to go here. I'm going to attach it to that external object. We'll do vehicle. And then I'm going to pass it through the body section, compile and save, and compile here. And I now have access to endo. The first thing you'll notice, hopefully, is that the front wheel is a little off. and not correct. And the reason that's happening is because it's using the reference pose of endo as the main skeletal mesh, but we can fix this. And I can show this even further if I load in the spoiler. It's kind of in the wrong spot. It's kind of in the same spot that endo is. So the way that we do this is we can use pose assets to pose the mesh prior to pulling out the section information and then baking that together. So I've got a data table set up here where inside of this data table, I have our mesh that we care about, and then a pose asset. And if you're curious how I created these pose assets, it's pretty straightforward and easy. I'll go to our meshes. I'll load up Octane. And then what I can do is I can go to the preview settings here in the skeleton in particular, and I can swap out which preview mesh I want to look at. And for some reason, endo's not in here. But if they share the exact same skeleton, it'll appear in here, and I can choose that mesh, and then choose Create Asset, and up here I can create a pose asset. And the output of that current pose asset by using the other preview mesh looks like, pull up my data table here, I go to pose endo, it's a modification of the bones to that position of endo. And we can use this inside of our car example. So I've got this data table, and I can export this pin. So this export pose asset pin, which if you pull a pin off here, you can see export pose asset pin. What this does is it takes the variable here and makes it usable in all the child customizable objects. And from there, what I can do is I can go to the endo mesh, and I can use a new node called pose mesh, and I can plug this into the body, intercepting it, and then I can do import pose asset pin, and then I can specify, just like the other child-parent relationships, Bali, vehicle example, and I want to grab that base pose pin. I can plug this in, compile and save, and go back and compile this, and now I have a new, because of the data table, I have a new option here, and I can choose endo, and now I've got a much cleaner example of how it should be set up where I can pose those wheels in the right spot. So there's some cleaner ways and more efficient ways to do this where I can choose the body and it will automatically choose the right, pose asset and things like that. But I want to show the idea that the skeletal mesh is really important and that reference pose is really important, but we can modify it. And one of the things that you can imagine is that, say I'm building a character customization system and I want to have masculine and feminine bodies, for example, with different structures, but I want to still share assets on those things. You can utilize this to kind of repose some aspects of your mesh to fit that body type. Okay, so I've shown a lot to do with meshes and how we can combine textures as well as utilize those materials to get the most efficient things. But what if I want to change color or textures and things like that? So I added a body color parameter here. You can right click and inside of this, you can type parameter, and there's all kinds of different types of parameters that you can use: mesh, texture parameters, enum parameters. These are all inputs that you can use to actually be driven via Blueprint or C++ or whatever system that you can pump into your customizable instance at runtime to modify data. So I'm going to take my color parameter. I'm going to export that here. I'm going to compile it, and then I get access to a new color. And I'm going to, in endo here, I'm going to import the color pin, and I'm going to associate it with the parent, because you should always call your parents here, and associate it with our color parameter, and I'm going to hook it into the body color here. And if we look, I've exposed the base color as a parameter here to modify on the material instance that gets created with Mutable, and you can expose any parameter that's associated with a material. And the cars that are inside of the engine have a bunch of other things like car length and things like that. Damage, for example, you can pump through like how much damage a vehicle has and whatnot. We're just going to do color today, but once I compile and save this and go back to our example, I can now create that pink spoiler that I wanted. So we're going to go back to double check what's going on there. Compile, save. I can create a pink version of the car here. And then if we go here to compile, okay, I've got my pink version of Endo that I've always wanted inside of Rocket League. But the idea here is that now I can drive this via Blueprint and also be able to customize all different aspects of these vehicles. So the advanced version of this, and this is the first time I'm going to show the Mutable sample version, because again, it's a little bit daunting to get into if you haven't been in here and kind of shown some of these basic features. But if I open up CO character, there's a lot of information inside of here. But in this case, the character that's inside of the Mutable sample has the ability to have aged helmets, bodies, fuzz parameters, cloth, tattoo projections, and colors. If you want to handle skin tone, you can take this Curve Atlas style texture, plug it into an input texture, have your skin tone float parameter, and you can sample from left to right on the x-axis, and then output that as a color pin. And ultimately, what you get is you get something like this here, where I can now change the color of the skin of my character through this Curve Atlas. And then on top of that, you can also do things like interpolate textures between one aged texture and a non-aged texture and blend them together, interpolate, those aspects. It's very powerful, and you can start to get really clever with your child object setups to drive those parameters and create any customization that you want. And because I showed that you can do this on weapons and vehicles, any skeletal meshes, just think of them like characters, and now all of a sudden you could have damaged cars that you can animate and stuff like that. And it's really powerful. And the output of this, again, runtime or baked, very efficient. So that's the end of my live demos for now. There's always a lot to cover whenever we talk about Mutable, but these are videos, just in case. But there also are some limitations. So it can be used in a lot of different places, but it's not free. And I want to highlight these because as you get into this and you get into your games, you're going to run into these issues, and I want to kind of head those off ahead of time to have you start thinking about how to solve them. So the first one is your runtime consideration. It's not instant. It runs asynchronously, which is a good thing because you're not blocking your frame at the time in which you're generating your assets. But it also means that if you expect your asset to be available to you exactly when you create customizable instance, it's not going to be ready. So make sure that you hide the mesh underneath until it's ready to go. There is a callback that you can hook into that says, hey, I'm done. And then you can show the mesh. It's very memory demanding. So if you are a memory constrained project for mobile or anything like that, you can, if you're using it at runtime, it's going to use up some memory because it generates all these assets at runtime into memory. And you're going to want to think about how much data you're using. Because we're combining meshes and textures, we are creating more memory efficient objects, but it's going to use it. So keep that in mind. And just like I showed with the skeleton chain setup, it is skeleton chain dependent. But I want to highlight the example of a backpack. So you have your body skeleton, and then you have your backpack. What you want to do for attaching a backpack and combining those skeletal meshes is you'd have the root to the pelvis to the spine, 1, 2, 3, 4, 5, and then hook into your backpack to kind of hook those things together. But it will still animate from there. Another consideration is your connecting systems. So Mutable is not a UX or UI system, but it has metadata for UI and UX systems inside of it. So I show an example here. On your customizable object, that blue node that I always rename to be like jacket or t-shirt, and then you attach it to the parent, there's a UI metadata section. So if you can imagine all of those sub-customizable objects that we create, we can add our thumbnails and our name of things, and then we can access that information once the object gets created from our blueprint and pump it to our UI. So anything that's being used for those particular child objects can be accessed, and you can be like, okay, well, I want to choose the jacket, so you get the customizable objects from your asset directory, but then once that happens, you can like grab the specific UI from that. Another thing is if you're a live service game and you have services connections, you want to be considerate of how your services drive this data. And I don't have any specific solutions to this. I've just ran into it in the past. So in your services, in your cloud or wherever that, you're going to want to create some association between your, I've got a t-shirt in my backend services, and that's going to drive, okay, it's this t-shirt customizable object through blueprint or code or wherever it makes sense. And you're going to want to be considerate of how those things attach. The other consideration is performance. So even though Mutable's goal is to create more efficient and optimized meshes, you're still creating skeletal mesh components, and you can get more characters in the world, but skeletal meshes on their own are expensive. So keep that in mind when you're generating large crowds, that you're still going to be paying the cost, especially in memory, for all those different versions of the character. Another thing to consider is large customization systems. So longer compile times, if you have giant customizable graphs and child objects, there's not a great solution for this, but we are working on something, and I'll talk about that in just a second. The last thing is texture generation costs. There's a high cost for generation time for textures in general. So if you're combining and atlasing textures, just keep that in mind. So where's it going next? The first thing that we want to drive is dataless-driven customization. So all the things that I showed today, if you imagine those things as functions, so I've got a customizable object graph and I pulled in that skeletal mesh, but what if we took out the skeletal mesh part of that input, and that was like a parameter input to the rest of the function? All of a sudden now, you don't have to load all of those customizable meshes into memory. Mutable just becomes an operation center for doing things onto that data. So ultimately, this is going to help with continuous delivery projects where you like imagine downloading a mesh and then connecting it in through that system. But the other thing is that it's also going to make you're not going to have to create as many customizable sub-objects. You can just say, okay, this is the t-shirts that I want to add. The other thing is we want to continue to make performance improvements, especially on initialization. So right now, you can do all your customizations. Those run async, but then we need to apply it to the skeletal mesh that you saw, and that can be costly. So we want to make that better pretty much immediately. And then the last thing, we do support cloth inside of Mutable. There's a checkbox that says enable cloth. So you can pass through that information and it will apply. But we want to add better support for the system. There's some quirks to it. And we want to add support for the ML deformer. If you haven't used ML deformers before, I highly recommend them. They can do awesome stuff. And what we want to do is when you're applying all your ML deformers to like all those clothing and things like that, you want to pass that information through so it applies correctly. So once those meshes are merged, the ML deformer can take that into account, and you still get all the nice wrinkle motions without the extra cost inside of that as well. So some useful links for you folks. I'll keep this up for a little bit. But there's a lot to cover inside of Mutable. We've added some tutorials for Mutable in the Mutable tutorials. That's the first link that's there. And this will be online too, but you can go to the EDC and just type Mutable tutorials, and you'll also get that. As well as there's some reference documentation as well, so just deep dive on all the different nodes that are available in Mutable and what they do. You'll notice that's in GitHub, not the actual EDC. So that's why there's a specific link to that. And then lastly, go check out the Mutable sample project. There's a ton of info in there. There's lots of cool stuff. But hopefully with this basis that I've shown you on how to utilize the system today, just by following those simple things, you can start to navigate the sample a little bit better and easier and start to pick it apart. Because again, it can be daunting. But I highly recommend if you're a small team or you're a big studio and you have a lot of content that you want to combine, Mutable might be your answer. And with that, thank you. So I've been told I'm the last talk of the day, so I get to use this space for questions.
Okay.
So
I'm curious as to when you say runtime, it seems like you're generating the assets, but can you drive parameters live, meaning a car could take damage during gameplay, and could you even interpolate parameters or lerp textures?
yeah, you can. So there's a trick to that, and this is another catch. That's a great question. So you can drive those parameters. If you were to do it through the customizable object, and you change those parameters, it will actually regenerate the customizable object, and you'll pay that cost. So what you'll want to do is you'll generate your customizable object, but then in your blueprint graph or wherever you need to drive the other values, you can grab the material instance pins, just like a normal skeletal mesh, off of the customizable object and operate on those dynamic materials from that point on. So be careful of where you drive your damage and things like that from your systems. So again, just to reiterate, operate on the material instance that is an output. Don't do it at the front end there, because you're going to pay the cost of regenerating all the data again. There's another one over here.
Okay, thank you. I've been using Mutable for like quite a while.
Yeah.
And I'm very satisfied with it. That being said, I have like few questions, but I'm going to pick two of them today. First question, does it support animation post-process blueprint that passes through Mutable?
That's a great question. I'll just show it, actually.
Right.
So one of the downsides to Mutable is that it doesn't actually support animation directly. You can't combine anim graphs or anything like that. But what you can do, similar to UI information, you can send through on, I think it's on this here, not your mesh. Yeah, on your mesh. There's this anim instance node and the anim blueprint slot information, as well as this animation gameplay tag. And what you can do is you can specify, we recommend using Mutable with animation layers, for example. So you can specify an animation layer graph in here, and then it gets passed through the whole system as metadata, and then you can pump that into a layer, for example. It's a rough way, and I think they want to make that better in the future, but it's very usable because right now, animation graphs they're very static in their creation. There's really only one way to inject new behavior, and that's through the animation layers. And this is a way to do that. With the addition with UAF, that might change. We don't know, but in the future.
Okay, moving on to the second question. Do we need to have the same skeletal mesh reference for the other body parts and whatnot? So for example, like if we have the hair, we have a separate skeletal mesh.
Yeah.
Is that advisable for it, or do we need to have one skeleton for all of them?
Yeah, I think if I'm getting your question, so on the main mesh component, you have to have the reference skeletal mesh, but on the other subcomponents, you don't need to have the same skeletal mesh as your base, as long as they have the same structure, I believe. You get into some weird scenarios. I do recommend, in general, when using Mutable, that you try to reference the same skeletal mesh structure, if not the same skeletal mesh for all of your sub-meshes. And for the most part, you can add bones to skeletal meshes, for example, and some skeletal meshes will use them, but other ones won't. And that'll make your life a lot easier, just in case from a content perspective, like a bone moved, and now all of a sudden it moves in like the pose mesh example that I gave. But you can, as long as they have the exact same structure, they'll work together and combine. It does it by name when it combines the skeleton structure.
Okay, so I can have like part of the bone names from other skeletal mesh, like that. So it's kind of like that way.
Sorry, I'm not understanding the last part.
I mean, like for example, like if for the hair mesh we have starting from the head,
Yeah.
and then for the body starting from the root. Is that gonna work with Mutable?
Yeah, as long as your base trunk structure to get to the head part works, you can totally do that. And a good example of this is like, I don't want to have all the face bones in my body skeletal mesh, but I want to put it in my head skeletal mesh. You can combine those together. As long as you get to the head, you're good to go.
Okay,
Yeah.
that's it for now. Thank you.
Great, awesome. Does anybody else have any questions? There's one back there.
Thank you very much. For cinematics, is it possible to do in sequence, let's say somebody get hits or something to spawn textures and bake them in runtime for render queue?
Yeah. So I didn't show this, but I might be able to. So, if I add in we have access to our customizable skeletal component, the one that I added that holds the instance data. And what I can do is I can actually adjust information about my instance as a part of the track, and I can key that. So theoretically, I wouldn't necessarily do this because you're going to pay the cost of this, and it's very similar to the question on damage on material instances and whatnot. But what you can do is you can swap the whole customizable mesh on a keyframe here. And if I look at the details panel, I can choose a different customizable instance, and you can key that. But another thing that you can do is customizable object instance. It doesn't look like you're going to have as much access as you might think. So if I add the skeletal mesh component, the parent object that the data gets pumped into, I do get access to the material slots for each of those sections, and then you can start to drive parameters via that from there on the outputted data.
Okay, because we use a custom mesh switcher for like damage and stuff. We do cinematics, so the cost is not a problem. But sometimes we use decals and stuff like that, which can get messy because of stretching and so on. So a way of baking it into the mesh would be awesome.
Yeah, and this should allow you some parameters, some output parameters to do that. So, cool. Any other questions? Great. Well, good luck. Please use Mutable, check it out, and we want to hear feedback as well. So if you do start using it, send us feedback. The team, me, Chase Cooper, who's the product manager, we want to hear about folks that are using it. Reach out if you decide to start using it in your studio. And thank you.